Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 6 Statistics and Probability. Topic Probability. Subtopic Axiomatic Set Theoretic Probability. Connections with the theories of earlier classes. Probability of an event, probability of not, and or events. Exercise 16.3. Axiomatic approach to probability. Let S be the sample space of a random experiment. The probability P is a real value function whose domain is the power set of S and range is the interval close interval 0, 1, satisfying the axioms. For any event E, P of E should be greater than or equal to 0. 2. P of S is 1. 3. P of E union F is P of E plus P of F where E and F are mutually exclusive events. Probability. What is the probability of an event? If there are n elementary events associated with a random experiment and m of them are favorable to an event A, then the probability of happening of A denoted by capital P of A, read it as probability of A, is given by P of A equal to m by n equal to m is what? Number of favorable cases. N is what? Total number of possible cases. In this case, elementary events means the event consisting only one outcome. Addition theorem of probability. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B is again equal to P of A plus P of B if A and B are mutually exclusive events. P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. P of A union B union C is equal to P of A plus P of B plus P of C if A, B, and C are mutually exclusive events. Exercise 16.3. 1. Which of the following cannot be valid assignment of probabilities for outcomes of sample space S consisting of omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. P of omega 1 is 0.1, P of omega 2 is 0.01, P of omega 3 is 0.05. P of omega 4 is 0.03, P of omega 5 is 0.01, P of omega 6 is 0.2, P of omega 7 is 0.6. These values are greater than 0 and less than 1. Now we have to test that the sum of these 7 probabilities is 1, then these are valid assignments of the outcomes of the sample space S. Yes, as sum of all probabilities is 1, therefore these values are valid assignment of probabilities for outcomes of the sample space S. For B, its probability is 1 by 7 which are greater than 0 and their sum is equal to 1. These values are valid assignment. Yes, as 7 times of 1 by 7 is 1. B, its probability is greater than 0 and less than 1. Now sum of this probability is clearly sum of all probabilities is greater than 1. Therefore, these values are not assignment, not valid assignment of the probabilities for outcomes of the sample space S. No, as sum of all probabilities 2.8 which does not equal to 1. D. One of the values of probability is negative which cannot be happen. Therefore, no. As P of omega 1 is less than 0. E. All probabilities are greater than 0 but their sum is greater than 1. No, these values are not valid assignment of probabilities for outcomes of the sample space S. As summation of Pi is greater than 1. Question 2. A coin is tossed twice. Question mayek ama anirak huli. What is the probability that at least one tail occurs? Yamdrabara tail ama phambagi probability kayano. We have S consists of these four outcomes, and E, the set consisting of all those outcomes which consists of at least one tail is this. Therefore, P of E is n of E divided by n of S. N of E is 3, n of S is clearly 4, that is 3 by 4. For question 3, a die is thrown. Find the probability of following events. A prime number will appear. Ludu ama huli prime number ama phambagi probability puto haibani 1. We have S consists of 1, 2, 3, 4, 5, 6. Roman number A consists of 2, 3, 5, which are prime numbers. And P of A is n of A by n of A, whose respective values are 3, 6, 3 by 6 gets to half. B, if a number greater than or equal to 3 will appear. That is, the set A consists of 3, 4, 5, 6. Therefore, P of A is 4 by 6. That is 2 by 3. 3. A number less than or equal to 1 will appear. A number less than or equal to 1 will appear. That is 1 only. A consists of 1 only. Therefore, P of A is 1 by 6. Roman number 4. A number more than 6 will appear. A consists of A is equal to 5. That is, there is no number greater than 6 out of 1 to 6. A is 5, therefore P of A is 0. Then this shows that in this case A is called impossible event. Impossible event. Roman number 5. A number less than 6 will appear. That is, A consists of 1, 2, 3, 4, 5 up to 5. Therefore P of A is 5 by 6. For a card is selected from a pack of 52 cards. Card how many points are there in the sample space? Sample space the point kaya laigedagi. There are 52 sample points in the sample space. How many points are there in the sample space? 1 is over. For B, calculate the probability that the card is in a curve space. In a curve space, there is only one curve space. Therefore, probability of drawing an curve space is 1 by 52. Calculate the probability that the card is in a car. For C, Roman number 1, P of drawing an car. There are 4 cars in 52 cards. Therefore, probability of drawing an car is 4 by 52. After cancelling, we get 1 by 13. Black card. Probability of drawing a black card is there are 26 black cards. That is sum of spade in a club. That is 26 by 52, which gives half. Number 5. A fair coin with 1 mark on one face and 6 on the other, and a fair die are both toes. Coin amada face amadana mark face amadana 6 die. Aduga atopa die fair die amaga punna toes away. Find the probability that the sum of numbers that turn up is mathak to onkalakpa number sing tinjinaba poluna 3 tabagi probability putu 12 tabagi probability putu high bani. Here is the sample space consists of 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Hariba outcome singa siyaw sample space ta. Roman number 1. A consists of 1, 2 only, whose sum is 3. Whose sum is 3. Therefore, P of A is out of 12, 1 out. A consists of only one outcome. Therefore, its probability of happening of A is 1 by 12. Sum is 12. Sum is 12, which is also 6, 6. Outcome there is only one outcome. That is order pair 6, 6. P of B is 1 by 12. Number 6. There are 4 men and 6 women on the city council. If one council member is selected for a committee at random, how likely is it that it is a woman? City Council amada nupa taruk nupa mari nupi taruk lay. Council member ama khanabagi damakta random mi ama khali madu nupi oigani haibagi nupi. How likely is it that it is a woman? Nupi ama oigani haibagi chance kayano. Total number of members is 4 men plus 6 women. That is 10. N of S is 10. C1, that is taking one person from 10 it can be done in 10 ways. Let A be the event of selecting a woman. That is N of A is 6. C1, that is taking one woman from 6 is 6 ways. Therefore, P of A, that is probability of taking a woman, is NA by NS, that is 6 by 10. Who's cancelling? We get 3 by 5. 7. A fair coil is tossed 4 times. Coil ama taruk marirak hulli. A person win rupees 1 for his head. Head phangmama khudingi mi aman lupa ama phangi. Loss rupees 1.5 for his tail. Tail ama phangmagi lupa ama makai mangi. That turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses. Nahang mari mi amana marirak toss tarba matungda mahang paisa kaya phangadage. The probability of having each of these amounts. Adugumba amounts into phambagi probability su putu. Here S consists of these outcomes. When 4 heads turns up, Marirak hunbada heads ngaka laklabadi rupees 1 4 times the rupees 4 is gain lupa mari phangani. When 3 heads 110 turn up, head ahum laklapagi lupa ahum ama 1 tail ama turn up tobagi 1.5 khaidokrani, we get rupees 1.5 is gain. When 2 heads and 2 tails turn up, head ani phambagi lupa ani, tail ani phambagi lupa makai lupa makai khaidokrani, rupees 1 is lost. When 1 head and 3 tails is rupees 1 gaini 1.5 ahumra khaidokrani, we get rupees 3.5 is lost. When 4 tails 10 mari mak phangabadi 1.5 si mari rak khaidokrani, we get rupees 6 is lost. Therefore, probability of winning rupees 4 the out of 16 the one cases kaktang wari. The probability of winning rupees 1.5 phangabagi probability, the 3 heads phangabasi how many outcomes? 3 heads obviously the outcome mari lere for out of 16 that we get this. Probability of losing rupees 1 mang ba haibasi rupees 1 mang basi 2 heads 2 tails ni 2 heads 2 tails ki masing kaya out of 16 da 1 2 3 4 5 6 that is 6 by 16, that is 3 by I. P of losing rupees 3.5 phangmadi 1 head phangmadi madi rak mani 4 by 16, that is 1 by 4. Probability of losing rupees 6 mangmadi mari mak tails phangmadi out of 16 the amak yawi 1 by 16. I. 3 coils are tossed once. Coil ahum amuk tamuk hulle. Find the probability of getting 3 head ahum phangmani. Coil ahum amuk tamuk hun bahai basiga coil ama ahum lau hun baga sample space manai. That consists of these 8 outcomes in sample space ta. Therefore, P of 3 heads head ahum phangba higher the case ama kaktani out ni pa na 1 by 8. P of 2 heads head ani exactly phangba high basidi 1 2 3 cases like out of 8 3 by 8. P of at least 2 heads yamdrabadi head ani phangba haibani head ani phangba yamdrabadi head ani phangba haragadi head ani phangba plus head ahumok phangba case mari ni out of 8 we get 1 by 2. P of at most 2 heads yamabada 2 heads haibani yamabada 2 heads haragadi 2 heads head ani phangba head amakta phangba head sumphang phangdaba case in siloni yaron, that is 7 by I. P of no head amata phangdaba haragadi tail ahumok tail phangbabuni 1 by 8. P of 3 tails tail ahum phangba hairagadi 1 by 8. P of exactly 2 t's t ani kaktang phangba hairagadi case kaya yawi ti 1 2 3 by 8. P of exactly 2 tails tail ani ka phangba ikre. P of no tail amata phangdaba hairagadi head ahum phangba sibuni 1 by 8. P of no tail amata phangdaba ikre. P of at most 2 tails yamabada 2 tails haragadi yamabada 2 tails haragadi 2 tails haragadi tail ahum phangba case khanara out ni panda ama khaidokadi 7 by I. 9. If 2 by 11 is the probability of an event, what is the probability of the event not A? 2 by 7 habasi karigumba event amagi probability oirabadi event do phangdabagi probability kaya no. We have already learned that P of A plus P of not A, their sum is 1 is they two are mutually exclusive and exhaustive. Then P of A is 2 by 11, P of not A is written as A bar, and we solve P of A complement, that is 1 minus 2 by 7, that is 9 by 11, which is the required probability. Number 10. A letter is chosen at random from the word assassination. Find the probability that letter is a vowel, a consonant. Assassination mayakidi letter ama khangale madu vowel oigani haibagi case. There are 13 letters in assassination, of which 6 are vowels and 7 are consonants. Therefore, P of drawing a vowel is 6 by 13. P of a consonant is 7 by 13. 11. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? Hint: order of the number is not important. Lottery amada mi amana manadaba letter natural number taruk khangadabani 1 dagina 20 faugi manungdagi hariba number taruk aduna lot committee aduna hana khallaga leiba number taruk aduga mapa chanaba ngamlabadi mahakna prize phangani mahakna prize adu phangani haibagi probability kayano hangbani. There are 20 natural numbers from 1 to 20. Taking 6 different numbers from 20 is 26, which can be done. Also, number of favorable cases is the command Khaliba Manadaba number Taruktoga, committee Kalaga Tamiba Manadaba number Taruktoga Mapa Chana Bahaba City, Amukatamo Oitokani. Therefore, P of winning the 1 by of 26 can be expanded in this form and evaluate we get this, which is the required probability. 12. Check whether the following probabilities P of A and P of B are consistently defined. P of A is this, P of B is this, P of A intersection B is this. Let us found out. No, P of A intersection B whose value is 0.6, which is less than P of A or P of B. P of A intersection B is less than P of A or P of B. For Roman number 2, yes, P of A is this, P of B is this, yeah, their union is this. Question number 13, fill in the blanks in the following table. P of A is this, P of B is this, P of A intersection B is. What will be P of A union? Using appropriate formula, we get P of A union is P of A plus P of B minus P of A intersection. Giving their values, after simplify, we get 7 by 15, which has to be filled up here. For B, P of A is given, P of A intersection B is given, P of A union B is given. For P of B, we have to use this formula, put their values and solve P of B, getting 0.5. We have to fill up for Roman number 2, 0.5. Roman number 3, 3 values are given, 1 is left out. Using appropriate formula, there is this, we have to solve P of A intersection B, giving 0.15. We have to fill up this value 0.15. 14. Given P of A is 3 by 5, P of B is 1 by 5, P of A or B, find P of A or B if A and B are mutually exclusive events. These two events are mutually exclusive, therefore P of A or B is equal to P of A plus P of B, since P of A intersection B is 0. Giving their values, P of A or B can be written as A union B, whose value is 3 by 5, whose value is 1 by 5, getting 4 by 5. Number 15, E and F are events such that P of E is 1 by 4, P of F is 1 by 2, P of E intersection F is 1 by I. Find P of E union F. P of E union F is equal to this, which is P of A plus P of B minus P of A E intersection F. Giving their values and solving, we get 5 by I. For Roman number 2, not E and not F. P of not E is denoted by this symbol and not F is also denoted by this. And is replaced by intersection. Using De Morgan's law on complementation law on sets, we get this, which is again equal to 1 minus P of E union F. Remember this result. P of A plus P of B A not A is equal to 1. Using this, we get this. Put their respective value. P of E union is already found to be 5 by I, and we get 3 by I. Question number 16. Events E and F are such that P of not E or not F equal to 0.25. State whether E and F are mutually exclusive. Let us solve that. P of E bar E union F bar is equal to 0.25, which is applying De Morgan's law on complementation, we get this, which is again equal to 1 minus P of E intersection F. And solving P of E intersection F is 0.75, which does not equal to 0. No, E and F are not mutually exclusive events. Number 17, A and B are events such that P of A is 0.42, P of B is 0.4i, P of A intersection B is 0.16. Determine P of not A. P of not A. These values are given for Roman number 1. P of not A is denoted by P of A bar, which is equal to 1 minus P of A, and P of A is 0.42. We get subtract, we get this 0.5i. P of not B is also similar to Roman number 1, we get 0.52. P of A or B is in symbol P of A union B, which is equal to P of A plus P of B minus P of A intersection B. Giving their respective values and solve, we get 0.74. Number 18, in class 11 of a school, 40% of the students study mathematics and 30% study biology. 10% of the class study both mathematics and biology. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. Find the probability that he will be studying mathematics or biology. Here P of M is 40 by 100, P of B is 30 by 100, P of M intersection B is 10 by 100. Using P of M union B is equal to P of M plus P of B plus minus P of M intersection B, and giving their values, we get 3 by 5. 19, in an entrance test that is graded on the basis of 2 examinations, the probability of a randomly chosen student passing the first examination is 0.8, and the probability of passing the second examination is 0.7. The probability of passing at least one of them is 0.95. What is the probability of passing both? Here P of X is 0.8, P of Y is 0.7, P of X union Y is 0.95. X and Y are the events of passing first and second examinations respectively. Then P of X union Y is equal to this. Giving their values, we get this 0.55. Therefore, the probability of passing both the examination is 0.55. 20. The probability that a student will pass the final examination in both English and Hindi is 0.5, and the probability of passing neither is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing the Hindi examination? Satra amana examination English amasu Hindi examination animak ke examination amad pass tobagi probability as 0.5 ni. Animak pass taru have 0.1 ni. English pass tobagi probability ni 0.75 ni. Hindi pass tobagi have probability putu. Let E and I denotes the event of passing an examination in English and Hindi respectively. Here P of E intersection I is 0.5, P of not E and not I is 0.1, P of E is 0.75, P of S is 1. Since this equal to 0.1, which can be written as by using De Morgan's law, we get E union I's complement, which is again equal to 1 minus P of E union I's. And solving this value and expanding this left hand side, we get this, and giving their respective values, only one is left, that is P of I. Solving P of I, we get 0.65. Therefore, probability of passing the Hindi examination is 0.65. 21. In a class of 60 students, 30 opted for NCC, 32 opted for NSS, and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that the student opted for NCC or NSS. The student has opted neither NCC nor NSS. The student has opted NSS but not NCC. Let us solve. Let C and S be the sets of the events of who opted for NCC and who opted for NSS. Then P of C is 30 by 60. P of P of S is 32 by 60. P of C intersection S is 24 by 60. Roman number 1. We have to find out P of C union S, which is equal to this plus this minus this. Give their respective values, solve, we get 19 by 30. The student has obtained neither. Neither means P of C complement intersection S complement. Using De Morgan's law, we get this, which can be expanded in this form, and giving their value, we get 11 by 13. A student who obtained NSS, that is P of S intersection C complement, which is equal to P of S minus P of C intersection S, giving their values and solve, we get 2 by 15. Thank you for watching video.